All good? Good morning, everyone. Good morning, everyone here in the room, and good morning, everyone remotely, and welcome to the first webinar from the ARC Training Centre for Innovative Wine Production. My name is Vladimir Jiranek. I'm Professor of Enology at the University of Adelaide, and I'm the Director of the ARC Training Centre. Just as a bit of background, the centre has been in existence for some time now. We're in fact in our second iteration. We began back in 2013. We were fortunate to have a continuation or an extension of our funding into the current centre, and we're about halfway through. And the centres, for those that are not familiar with them, are an initiative of the Australian Research Council, and the objective is to encourage close interaction between universities and industry to tackle industry challenges and benefit the industry. And so this particular centre is focused on wine, and we have a suite of projects, and you can see the full suite of projects on our website. And those projects cover a range of challenges facing the industry, challenges around sustainability, profitability, changing market preferences, and so on. So you can see the full range of projects on the centre website. Today, we've got a snapshot of some of our projects. We've got 4 presentations from 4 of our PhD students who have been with us perhaps the longest. In total, we have about 12 PhD students who have been staggered in terms of their start over the last 18 months or so. The way that we would like to run this is that we will have a presentation and then a bit of time for questions after each presentation. I would ask that you actually write your questions in the Q&A box that you should be able to see at the bottom or top of your screens, and I'll read those questions out from here, and we'll get the answers from our presenters as we go on. So just to start off with our first presentation. Our first presentation on managing berry heterogeneity is from Claire Armstrong. Claire graduated in 2018 with an honours degree in chemistry from the University of Glasgow. She's in the third year of her PhD in wine science at the University of Adelaide, and she's due to finish in 2022. So I'll hand over to Claire. Thank you very much.
Good morning. My name is Claire Armstrong, and today I'm going to present to you my project on managing berry heterogeneity. So I'm just, I don't need it.
Yeah. The slide is working. It's just when you share. Okay, there we go.
Good. Okay. So my principal supervisor is David Jeffrey, and my co-supervisors are Vinny and Paul Boss. I would just like to say it's been a huge pleasure working with you all, and it has been wonderful undertaking this project. So berry heterogeneity can be defined as the diverse physical and chemical qualities of berries within a vineyard. For example, differences in berry size, seed number, seed ripeness, and berry color. Variable berry chemical compositions such as sugars, organic acids, phenolics, and volatile compounds. As we all know, sugars is the main parameter for determining the maturity of grapes in the vineyard. So when I say grape maturity, I'm referring to the sugar concentration throughout this presentation. So vineyards are variable temporally. So from season to season and throughout the season, there are huge differences. And this is mainly due to extremes in climate. So from drought to flooding and frost to heat waves. So shown here in the weather charts, you can see there's that huge differences between each year, and this really drives the variation that we see in the vineyard. Vineyards are also variable spatially, and this is so from one side of the vineyard to the other, and this is due to differences in soil type, soil depth, soil nutrition, water availability, slope, and elevation. And these are all parameters coined in the term terroir. So terroir is also really driving our variability in our vineyards. And this leads to variation between our vines. So we've got high and low yielding vines, more and less advanced vines, and these all result in higher and lower quality wines. So shown here is a couple maps drawn up by Rob Bramley here in Australia with Cyril. And he is just showing here the correlation between the variation in the vineyard. So where you have the yield map there, you've got that lower yield correlating closely to quality parameters such as anthocyanin and phenolic concentrations, and also berry weight with that correlation. So in this project, we're more interested in the less and more advanced vines and the resulting quality of the wines. You also get a large variation within a cluster. So you've got underripe berries and overripe berries. Our underripe berries have that high seed tannin content and the extractability, and also that big acid profile. The overripe berries have more skin color pigments and their extractability is higher, and they are packed full of sugar. So what does berry heterogeneity mean for wine sensory attributes and chemical composition for consumers? Previous research have separated out grapes by either their color or density and made wine from the underripe proportions, overripe proportions, and the optimal proportions. And they found that the underripe wine had a lower color intensity, lower pH, low scoring flavor aroma attributes, and had a lack of balance. The overripe wines were perceived as flat, hot, bitter, and had a high alcohol content. This is not desirable in the wine industry because of that higher taxation incurred and also the health implications associated with it. So what does berry heterogeneity mean for the wine industry? You've got that inconsistent wine style and quality from consecutive vintages from the same block. So what I mean by this is that you have a single block wine, award-winning, fantastic. Next year, you measure the same TSS, the same pH, the same TA, all the same mean, but it's just not got that high quality award-winning factor. And this is probably due to the hidden variability going on. If you've had a cooler climate, cooler season, you've probably got a shift to the underripe proportions. Or if you've been blasted with a lot of heat, you've probably got that overripe proportion there, and it's just reducing the quality of your wine. So I know that a few wineries can sort their fruit, so optical density or by hand, but the problem with this is that it's costly and timely, and yeah, just another step in that long process of winemaking. Vineyard managers also drop fruit, so the idea behind this is to have a more balanced vine, which ripens evenly. However, this is reducing your yield, and therefore you're losing out on a bit of money. So this year I have submitted a manuscript to the Australian Journal of Grape and Wine Research on my results from Eden Valley. So I'm just going to talk through some of those with you today. So as I just said, I was up in Eden Valley, super hot season. So we did harvest on the 13th of March, a bit earlier than normal. But what we did see from 5% braise on through to harvest was the, we were measuring the variability. So showing on the left for you guys, no, the right, is the distribution of sugar from each sampling date. So you can see that the distribution is very sharp to start off with. And I know we've heard a lot about flattening the curve recently, but in this situation here, it's not actually that desirable because it represents a higher variability. On the left for you guys is the mean sugar content. So we see the accumulation of sugar there is active. And then from the 4th of March to the 13th of March, it sort of peters off. And this represents the concentration of solutes by dehydration rather than accumulation. So I was out sampling and measuring the sugar and weight to calculate the sugar content per gram berry. And then I calculated the variation, the coefficient of variation, to represent the heterogeneity. So just looking at that closely, From about 5% veraison to veraison, we see that 11% increase in heterogeneity, which is expected. And we all know that veraison initiates unevenly across the vineyard. This has been related to seed weight and berry weight, and also uneven initiation of flowering, and is expected. A month later, we see a 20% decrease in variation, but just note that there is still about 25% heterogeneity there. So there is still variability present in the vineyard at this time. And then 9 days later, at the time of harvest, we see a 6% increase. We have related this to the uneven dehydration across the vineyard. As you can see here, there's that shift towards the overripe proportions of fruit, which is not desirable. So we wanted to investigate the grape heterogeneity impacts on wine quality. So what we did was, instead of having these separate proportions of fruit, we used a novel blending method. So we separated out into 5 maturity classes using density baths. And we made a low heterogeneity wine of just the middle bath, a moderate heterogeneity wine of all 3 baths, the 3 middle baths, and then the high heterogeneity wine with all 5 baths. We also had a control wine, which represented the inherent heterogeneity of the vineyard. And that's shown in the green dotted line. And you can see that it was slightly shifted to the underripe proportions, ever so slightly, and was sat between the low and moderate proportions of the middle class. So we put the wines through sensory analysis and chemical composition analysis. And I'm just going to show you some of those results here in this biplot. So I did principal component analysis on the significantly different sensory attributes and chemical composition. And I'll just talk that through with you. So the main separation was separating out that high heterogeneity wine with from the low heterogeneity wines, and that accounted for 66% of the difference. And then the minor separation just had the treatment wines from the control wine. So pepper flavor, floral aroma, pepper aroma, and a longer fruity aftertaste was more closely associated to the low heterogeneity wines. And because these were opposite the high heterogeneity wine, we can say that it lacked these attributes. Sour taste was more closely associated to the higher heterogeneity wine. And then savory flavor was associated more to the high heterogeneity wine, but not as closely. From the 16 aroma, 16 flavor, and 8 taste attributes that I presented to the sensory panel, only these 6 were found significantly different. So from this, we can say that there wasn't the biggest impact on sensory attributes by heterogeneity within the wines. And looking at the volatile compounds, so these compounds are all from yeast derived, fermentation derived, and are usually more associated with the fruity and floral attributes. But as we can see, we didn't see that reflected in the sensory. So what we could say is that there was a masking effect going on, and this could be pronouncing the sour taste. These 3 compounds are grape derived, and they are more associated to the lower heterogeneity wines. IBMP is a varietal compound, which is desired for stylistic preference. And the other 2 compounds are responsible for floral, which we see there in the sensory. Looking at the phenolic profiles, so the low heterogeneity wines were more closely associated to larger tannins, more total phenolics, more total anthocyanins, and more monomeric anthocyanins, whereas the high heterogeneity wine had a higher wine hue. And this sort of gives us an idea that heterogeneity may be stabilizing the wine color. So just to summarize what I've presented to you today, grape heterogeneity in terms of sugar content increases at the time of harvest due to uneven berry dehydration. So that was the graph I showed you with the overripe proportions shift. Wine sensory is minimally affected by grape heterogeneity levels, and high levels of grape heterogeneity may contribute to slight change in wine style. The level of grape heterogeneity at the harvest has an impact on wine phenolic and volatile compound composition. And overall, there appears to be a level of tolerance of grape heterogeneity as defined in this study for Cabernet Sauvignon, but must composition clearly has an effect on wine composition. I'd like to say a huge thank you to TWE for access to their vineyards and all the grapes sampled. I would like to say a huge thank you to all my sensory panelists and to everyone who helped destem and sort the berries. And a huge thank you to Renata and Nick for all their patience and help. And also a huge thank you to all of our support at the training center. Thank you.
Thank you, Claire.
Thank you.
Okay, do we have any questions? Whilst, and for those who are remote, please write your questions in the Q&A box whilst you're typing and questions are fermenting. No, we've got one there. Jason, outside voice.
Sorry?
Outside voice.
Yeah, outside voice. Great presentation. The differences in the dehydration of the grapes, is skin thickness, does that play a role in that variability in that dehydration of the grapes?
Yeah, probably it could definitely play a part. I think more so the actual canopy of the vine, so more of the vine characteristics might be playing quite a major role in that as well. Yeah, definitely.
Could I actually ask a question? So clearly there's an impact on the finished product based on the proportion of heterogeneity. It sounds like your individual berry picking was an excruciating exercise. How do you see that this might actually be applied in industry? Sorry.
I think being in the winery and seeing a high level of heterogeneity and knowing what it could be doing to your final product could help decide certain winemaking decisions. Okay. But also sorting your fruit to remove that 10% either side. Does that answer?
Okay, so to some extent, it's perhaps shifting the emphasis back to the vineyard to try to reduce the heterogeneity. Mm-hmm. If you've still got some, try and remove the worst 10%.
Yep.
And then beyond that, try and tailor the winemaking to manage that heterogeneity.
Yeah, exactly. Just understanding what it's doing to your style and quality. Yeah.
Excellent. Dave.
While I'm on that, would you say that you could handle a bit of heterogeneity? I guess we don't know the percentage, but yeah, you speculate.
Yeah, well, I would, from these results, I would say that you could handle quite a reasonable amount. I definitely wouldn't want to see those shifts going any more than what we saw. Yeah.
And what's good spread, both ways, or?
Yeah. Well, from previous research, when they do harvest later, they really do see those jammy notes coming through, those raisins and everything like that. So I guess, and then that high alcohol content. So I guess you would want a bit more of a balance, that acid profile coming from the underripe berries to balance out those overripe sugar fueled berries.
Wonderful. Thank you very much. Great presentation. Thank you, Claire.
Thank you.
Okay, our next presenter is Pietro. Pietro has a Master's of Viticultural Enology from the University of Turin, and he did that as a double degree arrangement with Geisenheim. He's been with us. I think Pietro was one of our second PhD to join, therefore he's the second speaker on the program. So Pietro, thank you very much.
Thanks for that.
All righty, beautiful. So today I'll be talking a little bit about some experiments that I conducted last year during my placement at Ijagala Winery in California, concerning the effect of crop load and water status on grape sugar accumulation and aroma development. And this is a little bit of a chapter for a broader PhD project that is looking at the sugar flavor nexus. So we're trying to understand the drivers of sugar accumulation and aroma development to sort of understand how to ultimately manipulate those processes and achieve the targeted quality. So why sugars and aroma compounds? Well, sugars and aroma compounds are key quality traits in grapes. Whenever I approach a relationship between two components, it's very important for me to look how these components, these traits are similar or dissimilar. And I have to tell you that actually sugars and aroma components in grapes are not very similar. And in fact, we have a lot of sugars, just about 200 to 300 grams per liter in terms of their concentration, and two main forms of sugars, glucose and fructose in our grapes. But on the other side, we have a huge number of aroma compounds. And we have many different classes of aroma compounds, many different chemical compounds with different properties within each class. And all of those compounds are present at very, very low concentrations. And not only these compounds are directly related to specific descriptors such as dark fruit, spicy, and jammy, but also they can interact, and this interaction can make the whole relationship more complex. So if we were to put the two bits together and add the temporal frame into the ripening process, we could use this very simplistic model to describe how sugar accumulation and aroma development happen in grape. So we have our grapes that are ripening. This is the case of 2019 Cabernet Sauvignon here at the University of Adelaide. And while this happens, we have an increase in sugar concentration. And we know that sugar accumulation happens in two very specific phases. There's a first very active sugar accumulation where the sugar is being transported from the leaves to the berries. And this is very active and driven by the plant and by the vascular tissues. But then starting at 20 to 22 Brix, any further increase of sugar concentration is related to a passive process of dehydration of the grapes. So we're losing water in our grapes, and therefore we are seeing our sugar concentration rising. And our understanding of how aroma development happens and fits into the sugar accumulation process is that there's a shift from green vegetal notes present earlier in the season to fruity floral notes later in the season that are much more desired. So let's say we were to pick our grapes at the end of this sugar accumulation curve, let's say at 24 Brix, we would have little green notes and a lot of fruitiness, which is exactly what we want. But this is very challenging because of climate change. In fact, because of increased radiation, elevated temperatures, and severe water stress, we are seeing a faster sugar accumulation in our vineyards. And also, we are seeing a more intense shriveling that starts earlier. So if we were to pick at the same sugar concentration, 24 Brix, to preserve the freshness of the wine, well, in this case, we would have to pick a bit earlier. And so we would have more green notes and less fruitiness. And this is why it's very important to understand the relationship between sugars and aroma compounds. So for the experiments that I'll be talking today, I developed two key research questions. The first one is, how does aroma development respond to different sugar loading kinetics? So if we have a faster or slower sugar accumulation and we get to the same targeted sugar maturity, what is the difference in the development of aroma compounds, and what is the difference in the concentration of aroma compounds at harvest? And the second one is, can we delay ripening instead of actually prolonging, extending hang time? Because when we extend hang time, we're going past the targeted sugar level. And so we have a higher sugar concentration, and because of shriveling, we're also having a negative effect on yield. So in a very simple way, and we can visualize the scope of the study in this model. So what I wanted to create was a model system with vines ripening at different rates. And I wanted to compare a standard sugar accumulation to a faster sugar accumulation, and based on literature and practical observation, cluster thinning seemed to be the way to achieve this faster regime of sugar accumulation. But at the same time, I wanted to create a slower sugar accumulation. And based on previous research at E.J. Gallo, I thought I could use this tool called late season irrigation or ramp-up irrigation. This means that we were adding extra water from 20 to 22 Brix. And we know that by that time, grapes are actually dehydrating. And so we thought we could actually pump extra water to slow down the rate of dehydration rather than restricting the metabolic rate of sugar import in the berries. So I did my experiment in 2 different vineyards, a Riesling block in the Central Valley close to Livingston, and a Cabernet Sauvignon block in Lodi, AVA, more of a premium vineyard. So on top, on the map on the top, we have a satellite view map of the vineyard. This was a 9 hectares vineyard with quite a bit of topography. The very cool thing, and I'm considering myself very fortunate that I was able to use this, is that I was able to use a very innovative system to manage the irrigation levels. As you can see in the mid map, those gray lines are creating some pixels, some units of surface. So each one of those squares is a 30 meters by 30 meters unit of surface, corresponding to 170 vines that I was able to irrigate differentially and remotely. So this system is called variable rate drip irrigation. And what I did, I basically selected 12 pixels, allocated them to 2 different levels of irrigation, late season irrigation being 50% more water than the control, starting at 20 Brix, and the standard irrigation, which was just 85% of evapotranspiration according to industry practice. And then within each irrigation plot, I had 2 different crop levels. So I had a low crop, which I created by cluster thinning the vine 1 week before veraison to 1 cluster per shoot. And then I had what I call the high crop load, which was no thinning. So basically not manipulated crop load, again, the standard for industry. So I'll just spend a second to explain to you how the system works, because this is a very innovative, nice, and very useful technology. So let's say that we want to irrigate differentially our pixel number 1 and number 2 in this map. So the way the system works is that for each vine row, in between the 2 pixels, we have this system that I'm showing in this picture. So we have 2 boxes, and there's a big box that is taking water from the main irrigation line and splitting it into a pixel on the left and a pixel on the right. And the extension of irrigation, meaning the hours of irrigation on one side, can be different from the other side. And this is just related to some very cool engineering techniques. It's probably just a little valve opening, and somehow it opens later or earlier. So the very, very cool thing about this is that the only thing I had to do to manage my irrigation levels was actually to create a spreadsheet with the pixel IDs on one column and the irrigation hours that I wanted on the second column. This was uploaded on the VRDI platform, and the vineyard itself was managing the irrigation for me. So remember, the aim of the study was to create a slower and a faster sugar accumulation and compare it to the standard sugar accumulation. So these are the actual sugar accumulation curves for the Riesling and the Cabernet Sauvignon. In the Riesling, we started late season irrigation at 17 Brix, where you see that dotted line. But we saw that out of the 4 treatments as a combination of types of irrigation and 2 crop levels, the main separation was just related to low croplet vines ripening faster and high croplet vines ripening slower. So we didn't achieve any significant delay in ripening by applying the extra water, neither in low croplet nor in high croplet. But in the case of Cabernet Sauvignon, the situation is a bit more intricate, and I'll zoom into that panel in a second. But the very important thing is that I was able to pick Cabernet Sauvignon wines, grapes, within the same block at the same maturity level of 26 Brix at 3 different dates. And the time span between the earliest and the latest harvest was 3 weeks, which is quite a bit. So if we look into the 20 to 26 Brix period of ripening, what I've done here, I've split the sugar accumulation curves into low croplet and high croplet. And this is very interesting because we're seeing that the way we create the 3 different sugar accumulation curves is just related to an interaction between the crop level and late season irrigation. And in fact, under high crop load, even applying extra water, we didn't find any significant delay in ripening. But by either applying cluster thinning only or combining cluster thinning and late season irrigation, we were actually we were able to create a faster and a slower sugar accumulation respectively. And of course, the aim of this study was to understand the effect on grape composition, and particularly aroma compounds, and also some other important compounds such as phenolic compounds. So I went out at harvest, and for the 4 treatments, I picked some grapes and I submitted them to chemical analysis. And I analyzed a bunch of parameters: aroma compounds, free and bound, phenolic compounds, and basic chemistry of grapes. And what I'm presenting here is a bit different from the traditional way we would present data. We are not comparing the 4 treatments for a single variable. We are not saying we have 100 ppb and 150 ppb of that compound, so we had a higher concentration in that treatment. Because I analyzed many different parameters, and because the study was actually looking at what are the drivers for specific compounds, I used this clustering analysis tool, which is a statistical tool that puts together and groups sets of varieties and helps to understand what they depend on. So, for example, all those compounds, they are listed as cluster 1, they were the highest in the thinned grapes. And then this was followed by thinned plus late season irrigation, and they were the lowest in the control, with or without the additional water. So we can speculate that those compounds are more dependent on crop load than on the extension of ripening. And there are some important aroma precursors there. They are responding to crop load more than anything else. The second compounds in the second cluster are actually not very present early in the season, and we can, but they were present at a very high concentration at the latest harvest. So we can say that those compounds, and there are important precursors of beta-damascenone and alpha-ionone in there, that were actually much more expressed and present in late grapes. And then cluster 3, those compounds are mainly driven by irrigation. And I want to point your attention to those 2 middle bars. So control and control plus water. And this is because when we looked at the sugar accumulation, these 2 treatments had exactly the same sugar accumulation. But with the addition of water, we were able to actually increase the concentration of all of these compounds. And it's a bit interesting that total anthocyanins, total phenolics, quercetin glycosides, and polymeric tannins, these are very important polyphenols that have an important contribution to wine quality in terms of color and mouthfeel. And they were actually increased instead of diluted when we added extra water. And then we have cluster 4. It's a bit of the opposite compared to cluster 1. So those compounds were increased in high crop load vines, and the trend was actually exacerbated by irrigation. So even higher when we applied late season irrigation to high crop load, and even lower when we applied it to low crop load. And finally, very nice and straightforward trend for the cluster 5. All of those compounds, the later we pick the grapes and the lower concentration we found for those ones. And we have very important green compounds such as C6 compounds and IBMP there, as well as other aroma compounds that are supposed to be volatilized over time. So there's been a lot of reports about delayed ripening, and this is another confirmation that delayed ripening is associated with an increase of quality. And I've tackled this strictly from a chemistry perspective. So looking at the drivers of quality in terms of chemical compounds that we know have a contribution on wine quality at the end. And obviously, replication of a multiple season is required to really understand the relationship between crop load and water status before we can actually say, well, if you really want to increase your irrigation, which is not a very environmental friendly thing, and I understand it, but if you really want to use that tool, you have to use that much water and that level of crop load to achieve that delay in your vineyard. But the main aim of the study was actually to understand all the drivers of these processes. And so it was a much more fundamental study by adopting these tools. And there are interactive effects of treatments applied. So it's very important to understand, as we did with this clustering analysis, what specific compounds in grapes are dependent on. So a refinement of the study and that analysis over multiple years would really help us understand how to tailor the viticultural practices to achieve the targeted quality. I really need to say a big thank to my supervisory team and for the sake of this presentation, in particular to Nick Dukuslin and all the staff at EJ Gallo Winery for their support and for making my experience in America the experience of a little Italian in a big America. And again, thank you very much. Any questions?
So we've got some time for questions. Any from the room? David Jeffrey from the University of Adelaide.
Pietro, it's always a tough one to answer this, I think, but what's the explanation saying cluster 3, the increase with irrigation of some of those compounds?
I'm just trying to look in any possible direction to understand that. I guess it is. I think there's a very important interaction between really the level of cropland and what changes when you change cropland in a vine, meaning, you know, the amount of light that you get into your canopy and all this stuff, and the irrigation, because phenolic compounds have been shown to be mainly driven by irrigation. But berry weights are exactly the same, cluster weights are exactly the same, so we're not seeing a dilution effect or a concentration effect. It's a bit weird.
It is, because especially if you think of the timing of when some of these things are being
Yeah.
emphasized as well. Yeah. So is it around some things? I don't know, it depends on your methodology, but could it be around extraction and some things are harder to extract based on the matrix in some way?
That might be something to look into, but I mean, it's just total answer science was just more absorbance. So maybe, you know, looking at better HPLC data or something like that would be very interesting to sort of have another proof that what we're seeing is actually what is there and it's not related to analytical procedures.
So I've got a question here. Have you checked the water quality in order to exclude the water contamination factor?
Not directly, but the whole system is obviously very controlled. There's valves there, there's pressure checked every time because of the system and because of the amount of technology that employs. There's filters ahead. So I'll have another look into that, but I'm pretty sure that well, what we're seeing, it shouldn't be related to contamination factors. But that's a very interesting question. You know, there's always more to look at.
Okay. Any more questions at all? All right, thank you once again.
Thank you.
So you can see the logos corresponding to our sponsors and our participants, which is again, it's a good reminder of just how diverse and collaborative this centre is, and we're very grateful to the support of our participants. Thank you, Pietro, for a great presentation. I know you're frustrated by not being able to have gone back to the US to do your follow-up vintage, maybe next year, who knows. But thank you very much indeed. So our next presenter is Eva Sui. Eva is actually a graduate of the University of Adelaide. She completed the Masters of Viticulturology here. She then lost her way a little bit and did work on potato vodka, but we're glad that we could bring her back.
More alcohol.
And she is now working as part of the training centre on white wine protein stabilisation. Thank you, Eva.
Thank you, Eva. Perfect. So good morning, everyone. I'm super excited to talk to you something about white wine protein stabilization. My project is using membrane filtration and proteolytic enzyme as alternative approaches. I'm Eva Sui, and my supervisors are Carrie, Richard, and Jackie. So as we all know, the transparency and clarity of white wine is very important to conventional white wine making. However, white wine can become hazy due to the exposure to heat or extended storage, and this is called heat instability. And this is because the presence of unstable proteins, but actually the proteins are quite stable because they resistant to enzymatic activities during fermentation and under winemaking conditions, and then they present in final bottles. However, they can unfold or denature due to stimuli such as heat or low pH, and they form small aggregates seen as a haze. And then the small aggregates cross-linking with other wine compounds such as phenolics or ions, and they form larger and get the sediments, form the sediments. However, the consumers perceive the haze or the presence of wine sediments as a poor indication of poor quality, so winemakers need to stabilize their wine. And wine proteins mainly extracted from grapes during winemaking, and all grape varieties have pretty much similar types of proteins presented, such as lipid transform proteins, thaumatin-like proteins, chitinases, beta-glucanase, invertase. However, not all proteins can form a haze. The three proteins highlighted in the red frame were identified as haze-forming proteins because they have been found in naturally formed sediments. And more importantly, thaumatin-like proteins and chitinases are present in a much higher concentration. So they are main focus of a lot of researchers and quantified by HPLC in my study. So how do we remove proteins from wine? So the most commonly used cellular practice is bentonite fining. And the negatively charged bentonite binds onto positive charged protein and then settled out as leaves and removed by ranking. The bentonite fining is good, it's cheap, and it's effective. However, its non-selectivity can strip other like favorable aroma or flavor compounds and also strip color from wine. And the settling of bentonite takes time when you add it to like large fermentation tanks, and the quality downgrade and the wine loss due to wine trapped in bentonite leaves can cost the industry a fortune, like up to $1 million per year. So other alternative approach, other absorbents such as chitin, the carbon dioxide, carrageenan, and most recently magnetic nanoparticles have been exploited. However, they suffer from either high dosage or cost prohibitive that's not adopted by the industry. The heat and enzymatic treatment on juice or wine has been exploited approximately 10 years ago. However, wine makers reluctant to heat up their entire wine or juice, and the membrane filtration, more specifically ultrafiltration, has been exploited approximately 30 years ago. However, earlier studies only focus on the permeate and ignore the retented. That's why they deemed the sensory profile changed. However, the membrane technology nowadays is more specific, like advanced, and both study needs more revisiting. That's why we come into this idea of combined ultrafiltration and heat or enzyme treatment. And so basically the wine will be filtered through ultrafiltration membrane and generate hopefully protein-free permeate and retented, enriched in proteins. And then we bring this protein-rich fraction only into heat and enzyme treatment to remove the proteins and then blend back to permeate to recombine the wine. So the working principles of ultrafiltration is actually the semi-permeable membrane acts as a sieve, which allows only small particles that are smaller than the pores pass through the membrane, and large particles retain in the retented. And the membrane were classified depends on the molecular weight cutoff specifications, and depends on the molecular weight cutoff you use. You can choose which fraction, which particles in which fraction. And for example, we want proteins staying retented in this case. And the enzyme we use is a mixture of aspergillopepsin 1 and 2 enzyme. We call it AGP enzyme. As we mentioned earlier, the unstable protein in their native states is resistant to enzymatic activity until they are heated and unfolded. And at that point, AGP enzyme can act as a scissors to chop up the protein chains, and the smaller peptides were not able to form a haze. This process have advantages over lacase control because lacase denatured after heating, and there were no adverse sensory effect based on previous juice trials. And food standard of Australia and New Zealand has approved the use of this enzyme, so it has been accepted by all major export markets. So before our bench scale trials, we have optimized our ultrafiltration, heat, and enzyme treatment, and the optimal condition were highlighted in bold. And we have identified that using a molecular weight cutoff of 10 kilodalton can achieve a heat-stable permeate and retain it highly concentrated in proteins. However, using a 20 kilodalton molecular weight cutoff membrane, we cannot achieve that. And we have identified practice works best among all candidate enzymes with a dosage of 30 milligrams per liter, and enzyme performs best at lower temperature rather than at higher temperature. And we pick heating for 10 minutes because we found the longer that you heat, the more protein you can remove, but we don't want to bring too much negative sensory impact because of heating. So we did our bench scale ultrafiltration, use this beautiful benchtop unit shown in the photo, and we have tested 3 wines, and the heat test result indicate all 3 wines were very high protein unstable to start with, which means it's suitable for the purpose of this study. And the diagram over here shows how the system works. So wine was pumped into the system and retained it, recirculate back to the feed tank. And at the same time, permeate passed through the membrane and continuously collected in another container. So the fractionate endpoint was when 80% of the permeate collected, which gives us the 20% of the retained. And when looking to the test result of all the retained, we found the delta NTU increased a lot. And with all the permeate were heat stable. And when looking to the protein concentration, we found a 3-fold of increase in all the retained samples. And then we bring this highly unstable retented to either heat or heat with protease treatment. And we found the result of heat plus protease treatment were wine dependent. There were 2 possible explanations for that, the initial wine protein composition to start with and the matrix effect. And from the result of SBS and SB1 as shown in the bar graph, we can see that the protein removal achieved up to 30 to 32%. However, the Masan wine achieved up to 96% of the proteins in retained with heat and protease treatment. And when we blend the treated retained back to permeate recombined wine, we found the heat stability of recombined wine improved a lot, with Masan wine almost achieve heat stable with either with heat plus protease treatment. And the remaining heat unstable, the remaining heat formation after heat test is because the presence of some heat stable somatin-like proteins and lipid transform proteins, as we mentioned earlier. So the bench scale work it works, but we all know that the sensory is very important. So we bring this to a larger scale in using a bigger machine, and we had 200 liters of Sauvignon Blanc wine to start with, which is unfine and very unstable. And firstly, we did the bentonite fining, traditional bentonite fining to achieve a heat stable wine, and we fractionate the rest of the wine in triplicate, and which gives us 10 liters of retained and 40 liters of permeate for each replicate. And then we directly put the permeate and retained back to see the implication of ultrafiltration itself. And then we did the bentonite fining of the highly unstable retained to form a stable recombined wine. And then we did a heat and heat plus AGP enzyme treatment on the retented, and we had up to 46% of the protein removal in with heat and AGP enzyme treated retented. However, we didn't remove all the proteins in retented, and that's why we still add bentonite to the heat and AGP treated retented. However, with the enzyme addition, we found the bentonite dosage decrease. And we also put the heat and AGP treated retented back to permit. However, the recombined one was not heat stable because of like the remaining proteins. So we did chemical analysis of all those treated wine, and we found the pH, TA, VA, alcohol level, and total sulfur were not significantly affected by ultrafiltration, heat, and or enzyme treatment. However, brown color and total phenolics significantly affected by any of the bentonite addition. And we also look into the wine volatile compounds and the signature Sauvignon Blanc style markers. However, we still need to process the data. So rate all that apply tests were carried out to study the sensory impact of all those treatments. And the spider plot of all those wines were pretty much overlap to each other, and we only found green apple on aroma and alcohol heat on mouthfeel, and overall flavor intensity was significantly different among all 38 attributes. And that means all the treatment were were very similar to the bentonite finding and no significant sensory impact. So to sum up, ultrafiltration of wine is very time efficient. So for example, if you are going to treat 20,000 liters of wine, you only need 1 to 2 days of filtering rather than like days of settling or up to weeks. And there were no negative sensory impact as we just indicate. And this is a cleaner method with minimal waste generated. And you can have a better wine recovery because you don't have lees. So my project provides better understanding of unstable protein removal and provide alternative options for winemakers to stabilize their wine and potentially reduce or the production cost by reduce or eliminating the use of bentonite. And likely a paper based on the result of my preliminary trial and bench scale trial has been accepted by the Australian Journal of Grape Wine Research like this week. So this will be, if you want to know more information, this will be all reached to you very soon. So I would like to say huge thanks to all my supervisors and my industry partner with Filtration, and especially all training center colleagues who have helped me with the experiment. Thank you.
Thank you, Eva.
Thank you.
So just a reminder, if anyone has a question and they're not in the room, please use the Q&A box to pose your questions. Do we have any questions from the room? Evelyn Bartowski from Lallemont.
Very nice presentation, very interesting. It's a long problem, a long and arduous problem for the wine industry.
Thank you.
How easy do you think it is for a winery to implement your findings in their current equipment?
Yeah, I think it's based on the size of the winery. Like, for example, small or medium-sized winery, if they don't have equipment of ultrafiltration, and there is my industry partner provide, how to say, renting of the equipment. Actually, you can treat their wine with their help. And for large wineries, they probably already have like a cross-flow system, and the only thing is to buy a membrane that's enable you to do the ultrafiltration. And for the heating and the like flush pasteurization, and like large wineries might already have like that system for cooling or heating, and I think it's more it's easier for the adoption of larger wineries. And the only thing is the availability of enzymes, because the enzyme I use is still chasing the approval of EU approval, but it will be on the market very soon.
Thank you.
Thank you.
David Jeffrey.
I'm curious what's happening with pH when you do ultrafiltration. Is the retentate higher in pH, and what impact might that have on denaturing and destroying these proteins?
Yes, the higher pH of retentate is only observed under my bench scale trial. However, in a larger scale for the sensory, we haven't actually see a big impact of pH change during the ultrafiltration, but the pH change might be might be because of some of the ions were rejected during ultrafiltration in a larger scale, and the lower pH might facilitate the protein aggregation. However, in my case, I found the pH would not have a significant role in the protein haze formation or the protein aggregation. However, the total phenolics level have a bigger role in terms of like protein removal and protein aggregation in my case.
We have a question online, I believe. So can you please indicate preliminary differences in cost between such membrane and nanoparticles?
Preliminary difference in cost between such membrane. Actually, the cost of preliminary trials, the machine was provided by our industry partner and as well as a membrane, and the cost, I guess, is only the the bills of electricity, probably, and power costs, yes.
And the rental fee, presumably.
Yeah, presumably the rental fee. And as I know, we did a calculation about the power cost. We only need 50 cents for per hectoliter, because it's fairly a quick process. And such membrane and nanoparticles, actually the membrane is quite fine, and we have looked into the surface of the membrane with very fine SEM, and we found the process is within the nanoparticle range. And I don't think the cost of the membrane would be a huge concern to the industry, because the membrane is you can use a lot of times, and as long as you have good hygiene practice, and you can keep using it and do a good maintenance on the membrane.
Could I just ask a follow-up question around cost? So you showed some examples of where you were able to reduce the bentonite requirement. Have you had an opportunity to do a cost-benefit analysis and show whether, even though the filtration and enzyme heat treatment doesn't necessarily eliminate unstable proteins, but does reduce the bentonite demand, is there still a cost benefit there in terms of reduced bentonite need, reduced wine losses? Have you done those calculations?
To be honest, we haven't, but because we want to bring this to a larger scale and really do the calculation in a commercial setting.
Sure.
And in that setting, the cost might be lower because we treat more volume of the wine, and it also very depend on the cost of the enzyme. So we can only probably answer that question until we know the price of the enzyme, but ultrafiltration itself won't cost that much compared to traditional bentonite fining.
We have time for another one. Yeah, there's another one on here, which is, have the membranes shown good repetition ability, or do they need to be replaced often?
No, actually, they do not need to be replaced very often. And as I mentioned before, as long as you have a really good practice of cleaning it regularly and just clean it straight after that, it's quite durable. And you can use it thousands of times, I think. And we use the membrane from a few years ago, and it's still working pretty well as long as you have like good hygiene and good storage for the membrane.
Excellent. Okay. Thank you very much indeed.
Thank you.
We are in the process of actually submitting a number of publications to the Australian Journal of Grape Wine Science, and we look forward to those actually appearing in a special issue sometime next year. So watch out for that. It'll be an issue which features half a dozen or so papers and review articles which are focused on research topics of the centre over its lifespan today. So our final presenter this morning is Colleen Szeto. Colleen graduated with Masters in Food Science and Technology from Cornell before joining the University of Adelaide and specifically joining the smoke taint team of Kerry Wilkinson. And she's going to tell us about smoke and fire. Thank you.
All good? Not sure. I probably don't need it. Am I good?
You're on.
All right. Okay, thank you, Vlad, for the introduction. Yeah, so I guess today we're going to talk about overcoming some of the challenges that are present in smoke taint, because there's a lot. So first, what is the actual issue? So as many of you know, I mean, it's hard to remember with all the things that have happened this year, but it's been quite a terrible bushfire season, both for the US on the right and a bit of Australia. I mean, obviously it extends further than that, but it's just some snapshots of January and October. And so it's neat because on the map on the right, you can see that even though, the fires are, are denoted with the orange X's, you can see the smoke drift. So it's like, even if there's a fire from hundreds of miles away, you might still be impacted by the smoke drift. And so the actual issue, this is what it might look out from your window. And so rather than having your wine reflect all the nice things that we want it to, terroir, winemaking skills, or what have you, it might actually be reflected by this instead, where wine's way defined by the barnyard, ashtray, metallic flavors and aromas that some of you might have had the pleasure of actually tasting this year in our sensory trials. So beyond that, there's a couple of considerations after smoke exposure between the point of when the grapevines are actually exposed and when you're actually holding that glass of smoke tainted wine in your hand. And so these are a few of them. And so the first questions that you might have to ask yourself as you're going along this phase is first, smoke exposure conditions themselves. Look, how much did I get? Or did my vineyard actually even get any at all? The second is for volatile phenol metabolism. It's like volatile phenols are a class of compounds that we know are associated with smoke exposure and things that we look for. And so, but there's a couple of different ways to measure them. They kind of change with time. And so it's just trying to sort out exactly what needs to be measured at what point. The third is, when you come around to harvest, should I even harvest my grapes? The fourth is if you decide to harvest them, you're going through winemaking, you're trying to sort out, what's the best way I should treat my wine? How should I try to mitigate smoke taint in every instance that I can? The fifth is, in the end, when you do have your glass of wine, is my wine smoke tainted? Can I trust my own nose to generalize for the perceptions of others? And so my research basically tries to answer a lot of these questions, but we're only going to focus on the questions of metabolism and try to sort out wine differentiation today. So for the first bit, for volatile phenol metabolism, I mean, before we even get our grapes, someone have actually asked me, are there wineries that actually let you kind of rock up with the big smoke box and contaminate their vineyards? The answer is no. You have to do it on a bit of an experimental basis. And so this is what it looks like out there in the field. So basically it's a big tent that encapsulates like 3 or 4 vines, depending on how wide they are. And there's smoke boxes on either side with just a channel to keep the smoke in the tent. Usually there's fans in there as well to try to keep it as even as possible. And so, yes, there's effects of fuel sources. People ask me that a lot as well, but we just use a simple straw because it's easy to burn, it's light to carry. And yeah, it's just something consistent across our trials. And so, I should also mention though that the smoke exposure is usually administered for an hour at 7 to 10 days post-veraison. And so in terms of the actual volatile phenols, this is what some of them look like. So we've got syringol, methyl guaiacol, M-cresol are some famous players, but there are a few others. And basically what happens is that the volatile phenols are glycosylated by the grapevine into glycoconjugates. And so this is a picture of one of those sugars. There's a couple different forms aside from this Gentia biocide. We have glucoside, rutinoside, stuff like that. But the main point is just to say, look, there's two different kinds of compounds that are important to measure in smoke taint analysis. And so in terms of how that's done, the volatiles are typically analyzed with JCMS, and then the volatile phenol glycoconjugates, at least in Australia, with the AWRI, we measure them with HPLC tandem mass spectrometry. However, there are other labs that do it differently, where they basically subject the samples to acid or enzyme hydrolysis such that the volatiles are cleaved from their glycoside compounds, and then the samples are subject to GCMS again. And so it's not so much, I don't want to focus too much on the instrumental details, but the point is just that there's a lot of different commercial services out there that are important for smoke taint analysis, and they measure these compounds differently, and the kind of information and the utility you can have from it depends on the type of analysis you get, as well as when you submit your samples to analysis. So unfortunately, when smoke exposure happens, it's not like you get all the volatiles, they get glycosylated, and you have a fixed number and say, this is what my risk profile is. From our 2019 field trials, we found there's actually a bit of an effective time. So what we did was, as the previous, I showed in the field trial photo, we took 3 vines, subject them to smoke exposure for an hour, and then we sampled an hour, a day, a week, and a month after that point of smoke exposure. And then we measured the volatile phenols and glycoconjugates. And so this is some of the patterns that we saw. On the left, so I mean, we have guaiacol and cresol, pentyl glucoside, but they're basically just examples of the kinds of patterns that both classes of compounds followed. And so for the volatile phenols, you can see there's a pretty giant increase right immediately after at an hour. But by the time you go back out there, 24 hours later, the concentration is significantly dropped down. And then for volatile phenol glycoconjugates, we can see that there's obviously a big difference between a week and a month. And so the time scale isn't consistent, but the main thing to focus on is just how different the concentrations were at a week versus what they were at a month. And so for going into 2020, we wanted to investigate both of these trends again and see, particularly for the volatile phenols, because some people might submit their samples only for volatile phenol analysis. And if they get out there a day later after smoke exposure, which is probably likely and very reasonable, you don't want to be there during the fire. So you basically get out there, you might actually substantially underestimate your risk if you go out at the wrong time and only measure volatile phenols. And the glycoconjugates as well. I mean, we were just curious about trying to get better resolution between that 1 week and 1 month, just to sort out what's the earliest time point you could sample such that you could realistically predict how much you will have come harvest time. So this is what the experimental design looked like for 2020. So like I said, it's pretty similar. The only difference is that we have a few more vines, and we also, just between the times of a week and a month, we had Monday, Wednesday, Friday sampling, just trying to sort out that resolution a bit more. And so, do the patterns match? For volatile phenols, they did. It's probably hard to read the exact numbers, but on the left, the mean concentration of guaiacol at an hour was close to 100 ppb. This year it was only like 15 or 20. So it's just, it was lower because I think we just actually administered less smoke. But I guess the main emphasis is that pattern is still there, where within 24 hours, they've significantly depleted. For 2020, the patterns were a bit different for glycoconjugates. And so in 2019, we see that massive increase between a week and a month. But you can see actually in 2020, the difference between 6 days and 20 days actually isn't significantly different. So I guess it's interesting to see that the pattern seems to level off this year, whereas last year there was a really big increase between a week and a month, which corresponds to harvest. So I guess to take this further, because I guess the next point of my research is just to sort out that relationship a little bit more and see what else might be happening, because yeah, this pattern wasn't exactly what we expected. So the first question I have to ask is, like, we've worked with the volatile phenols and glycoconjugates for over a decade. And so I guess the question, it might be time to revisit them and just kind of have a closer look at how predictive all of them are, because we measure about 30 compounds. I think AWRI is actually is capable of measuring up to 40 now. But I guess the question is, of those 40 compounds that we're looking at presently, which ones are actually just indicator molecules and which ones are the most predictive? And the second question might be to take a really holistic zoom out and say, well, are the volatile phenols and glycan conjugates as a whole class the most predictive compounds that are out there? And so what we'll be doing is actually taking a subset of the samples that I took from 2020 and subjecting to them to analysis by high-res mass spectrometry. And the goal is to, rather than having a defined method up front and saying, look, tell me how much guaiacol and syringol I have, just kind of taking the filters off and just taking a broad look and just saying, okay, what is all in this sample and what's driving separation between them? And so it might come down to something like this. I hope not. It might just be a matter of maturity because obviously, we've got a time course data set. But I hope that it's more like this, where there's actually a set of compounds that can be identified that really just kind of robustly differentiates control and smoke exposed grapes. There's also a possibility of an interaction where at different stages of maturity, there might be different things driving differences between control and smoke exposed wines. So that's going to be with a collaboration with Metabolomics SA, which is actually starting next week. So that'll be good. And so I guess the other thing, from industry's perspective, it's like, look, even if we found the perfect compound, based on the prices of current analysis and the timeline of current analysis, it's still pretty expensive. So for this is the current rate for volatile phenols and glycan conjugate analysis for a single sample. And it's also a bit up in the air because, as we've discussed, there's a bit of that time lag that still hasn't been fully resolved. So it's like, well, do I really want to pay $300 for a sample and have me be a bit uncertain? And even for wine volatile phenols and glycan conjugates as well, it can be even more expensive. And so the number up top for $750, that's actually analysis that's conducted by a lab in the US. So I did the exchange rate. That's why it's so high. But anyway, even if you quantified your wine, it's just like there's a bit of uncertainty as well in terms of how much we can relate chemical data to sensory data always. But I think particularly with smoke taint, because there's so many compounds at play, I think they can interact in interesting ways that can make it difficult to objectively say in wine X amount of guaiacol or whatever it is equals this kind of intensity of smoke on the nose. So basically, it's almost like at this point with these analyses, despite how far they really have made substantial progress, but it's almost like at this point where we're still looking at this binary system where it's like, you can tell me between between wines and grape samples that are severely tainted and then ones that are just not. But obviously we know that there's a massive spectrum between all that. And so what's important, I think, for industry is to try to focus on developing a rapid technique that can try to give you an idea of what your options are with a bit more resolution than what's currently existent for expensive analyses. And so you could say, given to have a method to be able to tell you whether given X amount of smoke exposure, can you harvest as usual? Can you have a light treatment, heavy treatment, or should you just not bother? And not bothering is a pretty hard decision to make, but I think it would be made a lot easier if there was an objective ruler to guide your decision making. So in terms of how we're aiming to do that, the approach is called molecular fingerprinting. And so when I think of fingerprinting, the first thing that came to mind was the board game Clue, used to play as a kid, but just the idea where fingerprints are usually used in a deductive way, where you kind of sort out, fingerprints are on the lead pipe in the dining room, and it basically allows you to figure out who did it, so the agent that was associated with some activity. But in the case of what we're trying to do, it's not so much, we don't really care so much about the actual compounds that are contributing to the fingerprint, so long as that the fingerprint can be used to give us information that we want, which in this case is whether or not grape or wine samples are, along that spectrum of smoke tainted, smoke affected, or unaffected. So the instrument that we'll be using to try and accomplish that is the Equilog, which basically is an instrument that's able to collect absorbance, transmission, excitation, and emission data. So in short, looking on the left, this is a picture of the EAM, or the excitation and emission matrix, where basically what it does is it takes a big range of wavelengths, in this case from 240 to 700, taking a scan every 5 nanometers and creates a map like this where different colors correspond to different intensities. And so and so I guess the dream would be to be able to use a grape fingerprint and be able to predict a wine outcome. But at this point in my research, I'm starting with wine and to predict to predict wine outcomes because, well, adding, going from different matrices makes it more difficult, but also, this isn't the first smoke taint wine classification study that's ever been tried. But I guess one issue that they kept that was persistent in limiting the efficacy of that work was that they used MIR data, not fluorescence data, but the idea was that they had trouble discriminating between oak exposed wines and smoke exposed wines because some of the compounds overlap. And so what I'm hoping with this technique is that we can successfully discriminate wines that are oak exposed and smoke exposed, try to overcome that obstacle. So in terms of what we've got for wines, it's a bit of a hodgepodge data set, but we have industry wines from NSW from this year, as well as from British Columbia. We have some wines from AWRI Commercial Services that they've generously donated to us. And also for unaffected wines, we have wines from the Barossa. We have a couple of, and we also have a variety of commercial reds and whites that have well, the reds in particular are likely to have oak exposure, but as far as we know, have no smoke exposure. And then we also have samples from my 2020 field trials in 2019 that have both control wines and smoke exposed wines. And so there's also a variety of data that's associated with each one of those classes. We're hoping to kind of pile it all together and sort out whether or not the information generated by the Aqualog can successfully discriminate between these wine classes. So in terms of the key takeaways from 2020, the first is just that, smoke taint metabolism or volatile phenol metabolism is difficult. There's a couple of different compound classes at play, and they have, the timing of sampling time is really important to sort out. And something that we're still investigating, partially with this study, where we're trying to, again, try to zoom out and really just make sure that we're looking at all the important compounds that matter. And while we busy ourselves with trying to sort out exactly what the compounds might be for industry, I think it's important to try to develop a rapid method that's less expensive, and can allow them to make more decisions in a timely manner. So with that, I'd like to make my acknowledgements to my supervisory team, as well as people at Training Center that have helped me out, and the Adam Gilmore in particular at Oriba that's helped me out with the Aqualog substantially. So thank you. Oh, yeah.
Thank you, Colleen.
No worries.
Do we have any questions?
Yeah.
Jason Amos?
Colleen, great presentation.
Thank you.
Jean and I, we sit on the RAC committee, and the smoke tank topic is highly relevant at the moment. What I found most interesting, the discussion has all been about, the multiple labs and trying to have.
Oh, it's a mess. Yeah. Yeah.
What I was not aware of is the time that you take that sample and the outcome that you get with that.
Yeah.
I don't believe the industry is aware of that.
Yeah, yeah, and it's hard because at this point we've only done it. If we found it last year in 2019 with Keb, but then this year's Merlot results were kind of like the volatile phenols did agree, but the galactic conjugates were still a bit. They didn't behave in the way that we expected.
No, and
so it's a massive issue.
Is that we can have some false negatives depending on the timing of that assessment.
I think most websites also, because I was scanning through, I didn't even think because there are multiple agencies that do it, but I think a lot of their recommendations right now are to sample as close to harvest as you can, which makes sense, but obviously for decision making and logistics is quite a nightmare. So yeah. Yeah.
No, but it's a really, really good project.
Yeah.
In terms of, we talk about, sort of the work and then making it apply to industry.
That's right.
This
Yeah.
is a hot topic.
Yeah. Yeah.
Where it's at.
For sure.
Yeah.
Thanks.
Yeah. Good. I would love to get to the point where we can communicate this variability on the timing of analysis.
Yeah. Oh, yeah, definitely.
Not that we need to predict, but what we need to do is communicate that it does have an influence yet.
Yes.
It does have an impact.
Yeah, but I actually, it would be interesting actually to speak with more industry people regarding like the timing at which they actually, when do they sample? Because I don't really know. Like I'm guessing it's not. I'm guessing it's not within an hour after the fire. So that's good. But yeah. I figured that, but I said, well, I didn't know, and I guess it also depends, like, how long is the smoke hanging out there, and does that have an impact as well? Does the timeline just continually get shifted further and further and further? the long the smoke is hanging there? Like, there's a lot of questions that are out there, but for sure, I mean, even under our very, I mean, as replicated as it can be, our trials, you know, you see it consistently, this kind of pattern. So it's definitely important to highlight for sure. Yeah.
Any more questions at all? Yeah, there's one here.
Ah.
Would you mind reading that one out, Colleen?
That's for Pietro.
I'm not Pietro.
No.
Okay,
Is that
great.
one later?
Yep. Okay.
Okay. Thank you very much.
No worries.
That concludes our presentation. So I should point out that Colleen also had the opportunity to work in California. The fact that she's working on smoke and there was fires in Adelaide and California, I'm sure there's no connection at all, is there? No? All right, well, thank you very much for that. So that draws our presentations to a close. Again, our placeholder slide here is a timely reminder to acknowledge the support of the participants in the training centre. Once again, I'd like to thank the presenters, not only for their excellent presentations, but in fact for being part of the centre and doing the work along with their supervisors. We're very grateful and very fortunate to have such an excellent crop of PhD students to contribute to our centre activities. I should thank Joe Sundstrom and Nick Van Holt for their support and technical IT expertise in getting us over the line with this first webinar from the centre. We are recording, or we have recorded this session. As soon as we get the final last few approvals, we will post this on the centre website, which you can find on the flyer which came with this session. Other sources of information from the centre, as I mentioned, there will be a special issue in the Australian Journal of Grape and Wine Science next year, so look out for that. There's plenty of information on our website. Again, you can see more about the various projects that are underway in the current centre, and in fact you can find links back to the activities of the previous iteration of the centre. And if you've got any more questions, please go ahead and contact the presenters, contact the individuals involved in various projects. You can contact me directly, and we'd love to hear from you. We are thinking about our future. We're already halfway through this current centre. We're thinking about where we'll go in future. I think we've got a fantastic amount of momentum and expertise, and so we are thinking about some of our project opportunities down the line. If you have any burning, pardon the pun, any burning issues, hopefully not just related to smoke taint, please get in contact with us. We'd love to talk about collaborations and joint research opportunities and ways that we can actually try and provide some benefit for the Australian industry. So with that, I thank you all for your participation. Thanks to those online. Thanks for your questions and your attention, and good day.